College Algebra Mac 1105, Chapter 1, Section 5. Uh, First thing I want to go over is the fact that you may have been taught, or if you have less than or greater than, you have an open point. If you have less than or equal to or greater than or equal to, you have a closed point. Well, now what's going to happen, we haven't really gotten rid of these, but instead of open points, we now use parentheses for less than or greater than, and we use a closed point and brackets for less than or equal to, greater than or equal to. On page 120 of your textbook is an excellent chart showing you the different types of graphs that you're going to have. Also notice that you have interval notation, you have algebraic notation, and you have graphical notation. For any problem you work for me from Chapter 1, Section 5, or Section 6, you must show me all three representations. If you don't show me all three representations, I will mark it wrong. So if we look at example 7 here, example 7 says 3 minus 2x less than 5. Well, the first thing I'm going to do is I'm going to move the negative 2x in the front, put the plus 3 in the back, and now I'm in two-step form. It's important to be in two-step form because now you know your two steps. Subtract 3, divide by negative 2. It also tells you that in two-step form that if the number with the variable is a negative, you're going to have to flip the inequality. On equalities, you don't worry about that, just with inequalities. That's the only difference between an inequality algebraic problem and an equality algebraic problem. So I'm going to subtract 3, which now gives me negative 2x less than 2, divide by negative 2, which I flip the sign. Now it gives me x is greater than negative 1. That means that if I look at this, I'm starting at negative 1. Because it's a greater than, I have parentheses. The arrow is pointing to the right, so I'm shading everything to the right. And so therefore I have my graph. So here's my algebraic notation, here's my graphical notation. If I want to go to interval notation and graphs are always read from the left to the right. So it's always coming from the left to the right. So anytime this is set up, it's always set up from the smallest value to the largest value. So as I read this for interval notation, as I come from the left, the first thing I hit is parentheses negative 1. As I continue on, I see it can go into positive infinity. Infinity signs, whether it's negative or positive, always has a parentheses. So here's my algebraic notation. Here's my graphical notation. Here's my interval notation. Notice that all three match up together. Here's example 8. It's a little different algebraic problem. This is where we have a variable on both sides of the equation. So what we're going to do is I'm going to subtract the 2x over from the 4x and get it in two-step form. Now that I'm in two-step form, I'm going to subtract the 7. I get 2x greater than or equal to negative 10. I'll divide by 2. I get x is greater than or equal to negative 5. There's my algebraic notation. Coming from the left, the first thing I hit is negative 5, which is a bracket because it's greater than or equal to. Going to positive infinity. There's my interval notation. So again, any problem you do for me on a test, I must see all three representations. I must see algebraic, graphical, interval, and they better match up. Here's example 10 in your textbook. This one here is sometimes referred to as a compound inequality. So what happens here is we actually have two inequalities here. We have, if I were to close and block this off, there's the one equation. And if I were to come over here and block this off, there's the other equation. But we're going to solve them together. So the first thing I'm going to do is multiply by 2 to both sides. Negative 1 times 2 gives me negative 2. 9 times 2 gives me 18. Next thing I'm going to do is I'm going to do the same thing that I did in example 7. I'm going to rearrange this so it's in two-step form. Put the negative 5 in the front, the plus 3 in the back. Now I'm in two-step form. Now I'm going to solve both sides at the same time. I'm going to subtract 3 from the 18, get 15. Subtract 3 from the negative 2, get negative 5. Divide by negative 5, flip the sign. I get 1 is greater than or equal to x. divide by negative 5. And I get x is greater than or equal to negative 3. So what happens here is whenever we have this intersection compound inequality, we never write a compound inequality in terms of greater than or equal to. Because remember what I told you before, it always comes from the left, which means comes from the smallest value to the largest. So what I'm going to do is move this negative 3 over here, because it's the smallest, move the 1 over here, because it's the largest, leave the x in the middle. When I move them, I got to flip the greater than or equal to signs to less than or equal to. So your answer should always be less than or equal to. So here's our algebraic notation. Negative 3 is less than or equal to x, which is less than or equal to 1. If I do my graphical notation, there's my negative 3, there's my 1, bracket, bracket, everything in between. If I do my interval notation, all I'm doing is really copying what the graph has. I have a bracket negative 3, bracket 1, comma, there's my interval notation. So see, you must know the relationship of the algebraic notation, the graphical notation, and the interval notation. And then also make sure don't make the mistakes of forgetting about dividing with your negatives and flipping your sign. Your biggest mistakes in algebra are going to be arithmetic in nature. And by arithmetic in nature, what I mean is you're adding wrong, you're subtracting wrong, you forget to multiply wrong, divide wrong. Those are going to be your biggest mistakes.